Walk into a modern skyscraper and you may notice something strange. You choose your floor before entering the elevator. A screen tells you which car to take. Then you step inside, and there may be no normal floor buttons at all. That is not a missing feature. It is part of a traffic system designed to move thousands of people through a building without turning the lobby into a crowded station. The story begins in Lucerne, Switzerland, in 1874. Robert Schindler and Eduard Villiger founded a small mechanical workshop. The company did not begin as the inventor of the modern skyscraper, and it did not invent the electric elevator, but it became one of the businesses that helped make vertical cities practical. In 1892, Schindler began manufacturing electrically powered elevators. That distinction matters. Electric elevators already existed, but the technology was becoming increasingly useful as hotels, offices, and apartment buildings grew taller. Before reliable passenger elevators, height created a simple problem. Every new floor meant more stairs. The upper levels of a building were harder to reach, especially for older people, workers carrying equipment, hotel guests with luggage, or anyone with limited mobility. Elevators changed the value of height. A top floor could become desirable instead of exhausting. Cities could place more homes, offices, shops, and hotel rooms on the same area of land. But elevators alone did not create the skyscraper. Steel frame construction, stronger materials, electric motors, fire safety systems, and modern building design all played important roles. The elevator solved one crucial part of the puzzle: moving people vertically. Schindler continued expanding its transport business. It installed its first escalator in 1936. After the Second World War, the company also became involved in railway and tram manufacturing. Schindler's rail activities eventually became a significant business, producing different types of passenger vehicles and rail components. But the rail division was separate from the elevator technology that would later change high-rise traffic. In 1997, Schindler sold its remaining rail vehicle activities as it concentrated more strongly on elevators, escalators, and related services. By then, skyscrapers faced a new challenge. The problem was no longer simply reaching the top. The problem was moving large crowds efficiently. Imagine the morning rush in a 50-story office tower. Hundreds of people enter the lobby within a few minutes. One person is going to floor 9, another needs floor 23. Others are heading to 38, 41, or 50. In a traditional system, passengers enter the first available elevator and press their buttons inside. The car may then stop again and again. Every stop takes time. The elevator slows down. The doors open. People enter or leave. The doors close. Then the car accelerates again. One stop is not a major problem. 10 stops during the busiest part of the day can be. A building owner could add more elevators, but elevator shafts take up valuable space. Every additional shaft can reduce the area available for offices, apartments, hotel rooms, or shops. The challenge is therefore not simply building faster elevators, it is organizing them better. In 1990, Schindler introduced Mechanic 10, an early commercial destination dispatch system. Instead of choosing your floor after entering the car, you enter your destination in the lobby. The system now knows where people want to go before assigning them to elevators. It can group passengers traveling to the same floor or to nearby floors and direct them to the same car. This reduces random journeys and unnecessary stops. The elevator may still stop several times. Destination dispatch does not promise every passenger a private, non-stop ride. Its advantage is coordination. Think of the difference between 10 taxis leaving with random passengers and a transport system that groups people heading in the same direction. The vehicles have not become faster. The journeys have become more organized. Modern versions can connect elevator assignment with building access. An employee may scan a badge at the entrance. The system can recognize which floors that person is allowed to visit and direct them toward a particular elevator. A visitor may use a screen. A hotel guest may use a room card. Some systems can also provide longer door opening times or other assistance for passengers who need it. This is why an elevator company can be considered part of urban infrastructure. Elevators are the vertical streets of tall buildings. Escalators and moving walkways perform a similar role in airports, railway stations, shopping centers, hospitals, and metro systems. When they work well, most people barely notice them. When they fail, queues form, journeys slow down, and parts of a building can become difficult or impossible to reach. The most important lesson is not that Schindler single-handedly invented the vertical city. It did not. The real story is how a Swiss workshop grew alongside the changing needs of modern buildings. First, cities needed safe machines that could carry people upward. Then they needed escalators and larger transport systems. Later, they needed software that could manage crowds inside increasingly complex towers. That is why the elevator with no buttons is more than a strange design choice. It shows how a simple lift became part of a coordinated network. The next time a lobby screen tells you to take car B, look around. You are not only waiting for a metal box, you are standing inside a small vertical transport station built into the heart of the city.